Right, so we are on review day 2. I highly advise you to have that packet, at least all of the problems attempted by tomorrow, because tomorrow's your day where you can grab me and like really fine tune, iron out the your deficiencies, like where you're not quite meeting the objective. If you get them today, I can guide you towards the correct video, so you don't have to, because you're not as good as at the objectives and understand the objectives as I am. So I can guide you. They're all labeled, but you can kind of gain there. So basically, that's what we're saying. Right. Today, I'm going to keep it as brief as possible. It's everything you know. Don't forget anything. But there are going to be some, slight adjustments. But so when I ask you for things like objective is find the angle between vectors. That one's easy because you're going to go straight to your formula sheet, which is the very back page of your packet, and there'll be the same one on your test. So you'll have so you get that angle by using the cosine theta is u dot v over magnitude of u times magnitude of v. All right, now, okay, so some of you might be, all right, so that's a lot of letters, but it doesn't mean much to me, right? But don't forget, u dot v is the dot product. This is your dot product. So if you have to go and watch a video on dot product, go ahead and do that. But realistically, if you understand that the dot product is multiply the x's from the different vectors, so multiply u's x to v's x, and then add them to the y's from the vectors. So multiply u's y with v's y, and then add those numbers together, and that is the dot product. And then you're going to divide that by the magnitude of the vectors. And the magnitude of the vectors is the x squared from the u vector plus y squared from the u vector multiplied. Now notice I'm saying u and u. Up here we said x from the u times the v. Now down here it's the actual, it's the magnitude of the vector. So you want its x and its y based on that right triangle there. So just find this is the x from u, and this is the y, this is the x from v, and then you do y from v squared, and that's it. Just plug it in and go. It's all on the key, everything's there. Try it, get to me, look it up, do whatever. That's all very simple stuff, but I'm just showing you where the formula is, reminding you about the formula. Then we can extend that a little bit, and we can go to an objective of taking a correction angle. So there's no big deal there. You just do the things the way you've always done them. So let me just pretend we're having a flying problem, and I'm supposed to be flying east. And let's just say the wind is blowing us to the south a little bit, and my resultant vector looks like that. There's my resultant vector. So I'm supposed to be flying east, but I'm getting pushed south a bit. Well, everyone on the plane wants to go where they're going, so they need to be flying east. So what kind of correction angle am I going to have to adjust? Well, you're going to do everything you've done. You're going to find out, you're going to do your inverse tangent. You're going to do your inverse tangent of your y over your x, just the way you've always done it. And then you'll find out, let's just say, we'll put a number in there for the fun of it. Let's say we're getting blown off course 3 degrees to the south. Well, it's very simple. You just point your plane 3 degrees the other way, and you'll get blown. So all I've got to do now is point my plane 3 degrees to the north, And then when that vector blows me south, guess what? It will blow me right on course. Okay, so whatever the direction is off course, put it the other way. Easy. Then, okay, so here's what I'm doing at this moment. This problem right here is giving you strategies. I'm giving you strategies to learn how to learn math, right? So there's certain types of problems you're given, and you have to kind of compartmentalize those. What's happening? Well, this is the one when I give you two vectors or many vectors. Vectors are given with angle between. So that usually comes in something like, you know, one guy is pulling, you know, like that, and another guy is pulling like that. What's the resultant vector on that object? Well, when you are given vectors and angle between the vectors, let's say that would be 100 degrees, then all you do, the trick, so let's write that in red, the trick is put one vector, lay one vector on the x-axis, and then do your r cosine theta, r sine theta the way you've been doing it. So I'll finish that up quickly, but you know, so I'm going to go ahead and I'm going to flatten down that vector. Can lay any one you want on there if you want. Doesn't matter to me. I lay the long one on there. So I lay the long one down there, and then 100 degrees away from that, I'll move the short one, right? And then I know this vector's got a component of r cosine of 0, r sine of 0, and this one's got a component of r cosine of 100, and so on and so forth, r sine of 100. So the trick when you're given angle between is flatten them out. Okay, nice and simple. Last but not least, and then you can practice for the rest of the period, is going to be finding objects in equilibrium. And the best way to describe that, I think, is tug of war. I don't know if they still have it, but when I used to have a kid, when I was a kid, they used to have a strongman contest on TV, and they had some kind of rope. They always had a rope right here. Let's make it just a straight line rope right there. And then they had like a flag on it. And, you know, I think they had to pull. There were all these strong guys, you know, on each end, and they had to pull it one way, and whoever got the flag over the line first won, right? Equilibrium means that flag will not be moving, right? Newton's second law. So when I push on the wall pushes back, right? And with equal and opposite force, and nothing's moving, right? So it's in equilibrium. So what that means is, so very simply, if this team is pulling at 75 newtons in that direction, how many newtons does this team need to pull for that flag not to move? 75 in the equal and in the opposite direction. Equal force in the opposite direction. So let's say, for example, make this easy. These are pulling 180 degrees. These need to pull at 0 degrees. If I turn this on its side and I was pulling at, this was 200, let's say this was 112 degrees. If this was 112 degrees, then I would need to pull this 112 minus 180 degrees. So that'd be what, 168? What? No. Okay, now that would work, but we don't go anything between 0 and 180. So, right, because I would pull, it'd be a negative. You'd pull. Yeah. If you did that on a test, I'm not going to grade it wrong. But just we'll treat it like that. So yeah, equal and opposite, equal force, opposite direction. That's all there is. And then that's in equilibrium, meaning it's not moving. Right? Nice and simple. Okay, so your job, crack through that packet. Hopefully, you really, I'm leading you to water. I can't make you drink. You really want most of that done by tomorrow coming into class to be able to generate questions to ask me. If you're so good, you can help other people. I can come up with some other problems that you would like more practice on, something, or, something like that, so that Friday will be a piece of cake. You don't want the first time you're trying to figure out how to do a problem to be on the test, especially since you got an exact copy. Okay, we good? Anything for the good? Okay, we're stopping.